organized. So we are going to spend, guys, a couple days now on word problems. So today we're going to focus on you reading a problem, writing the equation, and then solving for the unknown. So you're doing kind of everything. Tomorrow we're going to more focus on the ones where you actually have the equation given to you already and some unknowns in the equation that you substitute in and then solve for whatever variables left over. So those are kind of the two types. So if you have to build an equation, okay, this is on your formula sheet. You will be using this formula to build your equations with. So we're going to go through this formula, what it means. So obviously, if this is the formula you're going to use, which you don't have any idea what it is about yet, unless maybe you've seen it in science. Have you guys did some doubling and tripling and halving yet, exponential functions yet? No? Not a big deal. If you haven't, not a big deal. But if you're building formulas, they have to follow this trend, right? It's either building something exponentially or decaying something, right? So something's going to be growing or not growing. So decaying. So different scenarios like that could be bacteria, right? You guys have no bacteria questions? I know I've done bacteria questions with you in 10C, but you haven't done any of those in chem or anything yet? No. Weird. All right, so you will. So we know that with bacteria, can you guys picture bacteria growing at a very, very fast rate? Could you see it dying at a very, very fast rate? Right, depending on food sources and stuff like that. So those are scenarios that we're going to build equations on. Another scenario that's exponential is money. Okay, so when we invest money, we can also use this formula. So it'll be specific types of scenarios that we can use this formula to build equations. So let's go through what this formula represents. So again, y equals AB T over P is on your formula sheet, but it doesn't define each piece. You have to know what those pieces represent to be able to build your formulas. Okay, so y is going to represent your final amount, right? Can you guys picture that in lots of scenarios? Can you picture that with money? Can you picture that with bacteria? Those sorts of things, okay? So A is going to represent your initial amount. Easy peasy to visualize that. Okay, so what we start with. B, this is your growth decay factor. Okay, so this is your multiplication piece, right? So if it's going to be doubling, your B value is going to be a 2, right? If it's halving, your B value is going to be, right, I heard two different things, but if it's halving, your B value would be 0.5, yes, or 1 over 2. Now with percentage though, because with money, it's going to be percent. You guys picture that? So if it's growing, your investment is growing at 6% per year, guess what your B value is going to be? Oh, you guys are smart. I don't even need to teach you this lesson. Exactly. Does it make sense that it's going to be 1.06? Good. Awesome. What if it's a depreciation question? Your car is depreciating, and it's depreciating 4% per year. What would your B value be? 0.96. Good. So we're going to talk a little bit more about that. If that went over your head, I'll describe it a little bit more. So once we get to some examples down here. Because again, if it's a multiplication by a percentage, guys, you have to think if it's growing, right? What does that 1 actually do that you just talked about putting in front of the 0? Because you guys said 1.06 when I said it's growing by 6%. What does the 1 do? Right. It keeps the original. The 1 keeps your original amount. And then the 0.06 now starts adding on your 6% per year. Some of these questions, we're going to compound it differently. It's not going to be per year. We'll talk about that in a little bit. I don't want to actually bring that up yet. And then the depreciation one, if it depreciates 4%, when you put it into the formula, you got to picture, if I'm taking 4%, what do you still get to keep, right? So that's where the 0.96 came from. And it ends up being a 0 point. Does that make sense why the depreciation one's a 0 point? Right, because we're not growing anymore. So if it's decreasing, it's a 0 point. right? If it's increasing, it's a 1 point, and whatever percentage, right, that you're keeping. All right, so, and then the last two variables, the t is going to represent your total time. So if the investment's for 6 years, the t would be 6, right? If the bacteria is growing for 10 years, right, your t is 10 years, or 10. And t can be in years, it could be in minutes. It depends on the scenario that you're reading. Okay, so the units for time depends on the question you're reading. And P represents your period time. So the biggest thing with these two, if it's doubling every 2 minutes, your P is 2. These two go together. B and P, I always think Boston Pizza, right? They go together. Okay, so if you have a tripling every 5 years, right, your B is 3, your P is 5. Those two, time and multiplication factor, those two pieces go together. Okay, T is your total time, right? So if your total investment's for 10 years, T is your total time, right? So your total time versus your period time. Okay, does it make sense, the difference between the two? Right? Because again, if it's doubling every 3 minutes, right, but your bacteria is growing for 10 years, right, total time versus your growth decay factor time. Right. So it's important that we understand what each piece is, because then when we read the questions, we substitute pieces in. And right now, do you guys agree that there's 5 unknowns in this formula? Right? You'll be given, guess how many pieces? 4. Right? Because again, if I give you 5, does that make sense? Are you solving for anything if I give you 5? No. Right? So I will give you 4 out of the 5 pieces, and you'll solve for the one that's unknown. And can I ask you to solve for any of the pieces? Yeah, and that's kind of where we're headed. So you'll be given 4, solve for the 5th. All right, so let's take a peek here. So the warm-up is just making sure that pieces of the word problem, that B and P piece, you can pull out of a question. So for A, I apologize, this years is supposed to be way over here. Whoopsie. I didn't fix that, so the years should be here. Yeah. All right, so for A, just says the half-life of a radioactive substance is 6 years. So that's obviously not the whole problem, but I just want to make sure that we can really see the B and the P value in a problem. So if I gave you that piece of information in a whole problem, there would be more around it. Half-life would mean that the B value is 1/2 or 0.5, and the P is 6. Those two go together. They're talking about half-life takes 6 years. Boston Pizza. Okay. For B, an investment triples every 10 years. So again, your multiplication factor would be 3 and your P would be 10. So population of a town is decreasing at a rate of 4% per annum. So have you guys heard this terminology before, per annum? Right? So that just means per annum means per year. Okay. So just maybe put that in there. So per annum just means annual, which means per year. So then if it's decreasing at 4%, your B value would be 0, because what do we keep? 0.96. And your P value would be a 1. Because soon, guys, in the second part of the lesson, we will be doing, it might be per year compounded semi-annually, okay? So things like that's going to change our p-value because, well, I'm not going to get it myself. We'll do that when it gets here. All right, so let's just do some basic ones. So example 1 says in 2002, the population of a city was 160,000 people and was increasing at an annual rate of 4.5%. Write an equation to represent the population of the city as a function of the number of years since 2002. So we're just writing a formula. We're not solving for anything yet. So as we go through this, guys, what's the 160,000? What's that going to be? A So actually, I'll just write this. So y equals AB T over P. That's kind of our skeleton. So let's put the information we know in. So our A definitely is 160,000. And what's the only really other piece of wall? What's our B value? Perfect, 1.045. Anytime you're doing percent, guys, it needs to be, when you're trying to find a percent of something, it has to be written as a decimal, right? So 4.5% is a decimal, is 0.045. You're just dividing it by 100. And then we have to put the 1 back on it because that keeps the 160,000 people, right? And then the 0.045 after the 1, that makes it grow, right? And then the only other piece is it is an annual rate. So therefore your P is 1. So you're just left, again, I'm just going to write it so you guys can see all the information, right? But could I just write to the exponent of T? Yes. So that would be now a formula we could use to solve, right? And estimate if this growth continued at this rate, what the population would be in future years, or how long it would take to maybe grow to 200,000 people if this growth rate continued at a consistent rate. Okay. Yep, depending on the problems. Yep, because some questions will give you, say, minutes, right? So you'll still set the problem up in minutes, but then the answer they might ask for hours. So then just at the very end, you'll do the conversion. If everything in the question is in minutes, then do the whole question in minutes and do the conversion in your final answer. All right, so here it just says calculate the population in 2012 to the nearest whole number. So 2012 means how many years later? 10. So this just means, because we started the equation in 2002, so you did need to realize that this is 10 years. So that is your T value. So then I can use my equation. So y equals, so if this trend continues, in 10 years, they're going to be let's say nearest whole number, so 248,475 people. And we're done. So these are kind of fun to build. They don't get too tricky, right? So the tricky pieces are kind of what Josh was saying, in the sense of make sure you pay attention to units, because sometimes they will do that in a question where they're talking about minutes and then all of a sudden the final answer they want in hours. So that's just to make sure you kind of do a checklist of question is set up this way, and we will do some of those today, and they want a final answer this way, okay? But A, B, T, and P all are pretty straightforward when we read the questions. All right, so here it just says a certain strain of bacteria doubles every 6 hours. So if you want, you can start writing the variables. So double will be my what value? B. The 6 will be my P. So if the number of original bacteria was 350, so that is my A. How many bacteria will be present after 28 hours? So 28 will be my T, because that's the total time. So I have A, I have B, I have P, I have T. So y equals AB T over P. So this one we're just solving for the total amount. So this one's nice. We're not having to rearrange anything. So 350, 2, all my numbers in, sorry. That P is a 6. So 28. Please make sure, guys, this is where, again, the ones that have the 84 and above are at an advantage. Because if you don't, that 28 over 6 has to go in brackets, right? So please make sure you're very confident with your calculator when you're doing all of it. So, yep. It doubles? Pardon? No, it would still 1.5 would just mean 1.5 times, right? So it would still be growing if it was 1.5. The only time it's going to be decreasing if it's a 0 point something. So it didn't say how to round, so we'll just do to the nearest bacteria. So 8,889. Can we have negative bacteria?
No, nothing bacteria.
Then what? No. They won't be talking about going into debt. Okay. So any kind of values for money and bacteria population will be positive values. All right, so example 3 just says a patient who was feeling ill had a sample of bacteria taken from her throat. The sample contained 354 cells. 24 hours later, the sample was recounted and was found to contain 8,186 cells. Determine the doubling period of the bacteria to the nearest tenth of an hour. So what's our Y value? Right, so 8,000. Does that make sense, guys, that it grew to 8,186? So that's our final amount. So that's our Y. It started at 354. What's my B value? Yep, because it is talking about doubling, right? Determine the doubling period. So this is the key right here. Determine the doubling period. So that's my P, right? Is what I'm trying to find. So it is doubling. And then my T is, right? So 24 hours later, so that's my T. Because that's the total time, right? So 24 hours later, we ended up at 8,186. So that's the total time that we're looking at this scenario. And it does say find our doubling period. So remember, B goes with P. So that's what we're solving. Now, technically, guys, could you just throw that on your calculator and calculate it? Yes. To me, sometimes I find that takes longer. But so if we solve this algebraically, because that's what I want to do, I'd get rid of the 354 first. Do you guys agree? So I'd go 8,186 because I need to divide that off. 354, because remember, bed mass, right? The exponent is on the 2. It is not on the 354, so we got to get rid of that 354. I'm going to use that full decimal. So now I have 2 to the exponent of 24 over P. I don't have to write it down here, though. And could you just leave it as a fraction if you wanted exact? Absolutely. So guess what we're doing now? Changing. Right. Changing it to log, right? So changing to log form. So log base answer equals the exponent. So I'm just going to show, all of this can be done on the calculator, guys. I'm showing all this, but could you technically skip all this and just do it all there? Yes. So in the end, what I'm typing into the calculator, not 32. Just going to let you guys soak what I just did in before I type it in. I'm not going to type it in yet. Does that algebra make sense? And again, could you skip all that algebra? Yeah, I'm not going to say solve this algebraically. You could literally put into y1 8,186. Into y2, you could put 354 bracket 2 to the exponent of 24 over x. The only thing with that, guys, is you have to be good with your windows. Yeah, but I'm hoping you would look at that and go, okay, my y max better be more than 8,100, right? And then thinking of the period, just put a really big value for x, because then it'll calculate the point of intersection regardless. Because again, I don't care how you get the answer. The main thing with these word problems is they're checking to see if you can write the equation. But again, is it important that you guys understand the math behind it? Absolutely. Right, so divided by, so log base 2 of that answer. So I put the full decimal in there. So did you guys get 5.3? Yes, 5.3. Okay, good. And hours. Put our units. Did say nearest 10th. And we started in hours, and they wanted our final answer in hours, so I don't have to do anything fancy. Could they finish this question with how many minutes? Yeah. So you'd still do the same thing. You could have converted, I guess, at the beginning. But to me, I don't like touching the numbers, my original numbers, too much if I don't have to. We can just convert our final answer. All right. So example 4 says the population of germs on a dirty countertop doubles every 25 minutes. How long to the nearest minute will it take for the population to triple? So again, y equals AB T over P. So the 25 minutes, well, we'll do our B first. What's our B? Right, so double, so 2. And then the 25 is the P, right, Boston Pizza. And then the next part says, so it says for the population to triple. So it doesn't specifically give me the initial population, but do I need it with that information? No. So what I tell students here is, could you just pick a random number? Yep. So pick a random number. So I heard 5 the loudest. So don't write this down. I just want to talk to you guys for a second. So could you put a 5 here? If you chose to put a 5 there, then what would have to be your final answer? 15. Could you do that? Yes. So you could, in this scenario, pick a random number, or when we don't know something, what do we usually use? Right, an X. So if, again, doesn't matter. Some people rather concrete values. So, but if you choose an X, what would be it equal to now? 3X. Are they canceling out regardless? So regardless of what that piece is, if you pick an X and a 3X versus a 5 and a 15, we know that piece is dividing off anyway. You're going to get a 3, right, on the other side. So whatever you want to do, whatever makes more sense in your head, go ahead and do that. Yep. Can't set it equal to 1 because it's tripling. You could. Yes, that's what's going to happen right now. Yes. So because we know, so this X can be a 1, yeah, and then that would be a 3. So that's just kind of like the 5 and the 15 scenario. So you could have it start at 1 bacteria or germ, right, and 3. So again, you could start with any number you wanted as long as your output was triple that. Right. So then again, if you choose an X, regardless, guys, of what you choose for your initial amount, you have to make sure what's on the other side is 3 times that. So then whatever you guys pick there, divide it off. And then we have 3 equals 2 to the exponent of T over 25. And then from here again, you could use y1, y2, find the point of intersection if you chose to. I'm just going to change to log form. So log base answer equals the exponent. So this one's actually kind of nice. So then I can go log base 2 of 3, and then can I just times it by 25? Right, because I want t by itself. That looks like an x, so I'll use, I'm just showing my work what I'm typing in. So it looks like, so to, how long to the nearest minute? So if I have to do that to the nearest minute, it would be how many minutes? 40 minutes. Again, it was set up in minutes, so therefore I don't have to do anything crazy. So do you guys agree when we're setting up population growth decay questions, it's pretty okay where everything goes? It's pretty clear when you guys are reading stuff. So these ones, like I said, students are usually, yeah, that's not horrible at all. Okay. These are the ones that become a little bit more complicated just because you haven't had a lot of work with compound interest. Have you guys heard of compound interest before? So what compound interest is, guys, is when you deal with money in a bank, okay, whether it be a mortgage, an investment, whatever the case may be, your money either accrues interest or you owe interest, right? Mortgages, we pay lots of interest, okay? When you invest money, you make interest. But how it's compounded can change on depending what scenario you have. So most mortgages are compounded semi-annually, which means that you are charged interest twice a year. It's every 6 months, okay? When you're dealing with investments, that's kind of where you go shopping around, okay? Because with investments, do you think you want more compounding periods or less compounding periods? More, because more compounding periods mean you get more interest on your money more often, right? Because if it's compounded monthly, that means they're calculating interest on your money every month and it gets added on, okay? And then you have that little bit of extra interest now on your principal for the next month where it gets calculated again, okay? So for investing, right, and you're collecting interest, more compounding periods is better, okay? But when you're have a loan, right, and you have to pay interest, you want less compounding periods. So this isn't the hard part. Students don't not understand that. It's just how does it work in the formula. So you do have to get familiar with this, and most of them kind of make sense. So annually means once a year, okay? Semi-annually means every half a year, right? So every, if you think of it in months, every 6 months. So it's half a year. So then quarterly means every, think about that though. If it's 4 times a year, it's actually every 3 months, but it's quarterly. So it would be a quarter when you're thinking of your P value, because these come into play with your P, right? This is where these are going to come into play in the formula. These are going to be our P values because that's going to be our period, okay? So if it's quarterly, yes, think it's every 3 months that you're going to be collecting interest or owing interest, but in the formula, quarterly, it's exactly how it looks. You're going to put 1 over 4, okay? If it's monthly, yes, it's every month you're going to accrue interest or pay interest, but in the formula, it would be 1 over 12, okay? If it's annually, it's just going to be a 1. If it's semi-annually, it's going to be a 1 over 2. So just you have to think about what fraction of a year. So, and then weekly, there's how many weeks in a year? 52. So the B value, okay, in the formula, if it says weekly, I've never actually seen one on the diploma. It's usually semi-annually and quarterly are the two favorites. But if it did show up, it would be 1 out of 52. Okay. And then daily is more of a credit card, believe it or not. Okay. That's why credit cards are very bad if you don't pay them off. When you take out cash, right, it's daily interest. Okay. So 365, if you never seen this one on the diploma, but if it did, it would be 1 out of 365 would be your B value. Okay. So how these are going to work, let's just do a few so I can show you guys. So, and the other thing that these guys affect is, right, our B value. Okay, and I'm going to show you how it affects our B value. So let's do one where that's like just a straight, this would be the easiest one. When it's compounded, guess which way? Annually. Those are our nice ones, which we kind of actually did one already. So here it just says 5,000 is invested in a 7-year GIC compounded annually at a rate of 3.5% per annum, so per year. Determine the value of the investment at the end of the term. How much interest was earned? All right, so we have y equals, I'm just going to write the formula down again. All right, so A is what? 5,000. Right? And we're making 3.5% per year. So that's an investment. So what's my B value? 1.035. Right? You can picture this one, like, guys, as a population growth. It's the same idea, right? When it's compounded annually, it's the same idea. There's no kind of adjustments of anything to do with A, B, T, and P. And then how long is this being done for? Total years? 7. So that's our T. And our period time is compounded annually. So our P is 1. So then we can just type it in. So nothing was adjusted because it's compounded annually. 0.035 to the exponent of 7. So remember, guys, our Y value, go back to the beginning. Our Y is always our total amount. Do you guys agree? So, in this question, it did ask how much interest was earned. So did we actually earn $6,361.40 in interest? No. So remember, this is our total. So we have to do what with 5,000 in our total? Subtract them. Because the money in our account we started with was $5,000. Our account now has over 6,000. So the difference is the interest. So sometimes, guys, so that's another piece. Please read the question carefully, because sometimes they'll just say, what's the total amount of the investment? So you just leave it as the over $6,000. But in this situation, they do want the interest earned. So $1,361.40. So when it's annual like that, to me, this question is basically what we did above. Nothing kind of crazy. Everything just went in beautifully, and we did our calculations. Okay. But what happens when it's non-annual? Okay. So this one says $6,500 was invested in a 10-year RRSP compounded semi-annually at a rate of 6.4% per annum. Determine the value of the investment at the end of the term. Okay. So when it's compounded semi-annually, that again is our P value. So our P value is going to be what? 1/2. The other thing it affects is our 6.4%. Because you guys agree that our 6.4% is per annum? So it has to be broken up into 2 pieces. So all you have to do to get your B value is not going to be 1.064. It's going to be 1.032. Okay. So this is the annual rate, right? So this is the annual. So you have to divide it by 2. So if it was quarterly, guess what you would divide it by, right? 4. And again, you're actually timesing it by a half. Does that make sense? Yeah, you're timesing it by a quarter. So whatever your P value is, that's what you're actually timesing your percentage by to get your, in this situation, your annual or your semi-annual rate. So you do have to make an adjustment on your B value when it's compounded something other than annual. Because otherwise, guys, if you didn't do that, this person's actually getting 12.8%. Right? So if you didn't divide that by 2, they're in total, because you're giving them 6.4% the first time they get interest and 6.4 the second time they get interest. They would be happy, but it's not reality. Okay. So now once we have that, we can put all our information in. So again, we start with 6,500, right? Our B value now is 1.032. And remember, that's our semi-annual rate because it's set up semi-annually, right? And then our total time is what? 10. And our B value is 1/2. So that's going to turn into a nice number. What is that actually going to equal? That'll equal 20, right? So sometimes students just like, I don't want to even write that. Let's just put a 20. Hello? Yes. Yeah, if you just Google 30-1 released items, they all show up. Yeah. Pardon? No. Right. Yeah, I've always just went and found them all. Yeah. Yeah. Okay. Okay. Yeah, pretty much. Okay. Awesome. Bye. Sorry. So, did you guys punch it in? What do you guys get? Nobody punched it in yet? 1.032 to the exponent of 20. And the value of the investment is, what is it? That doesn't make sense. Pardon, Nate? Okay. So 12,200. 12,200. 12,204. Sorry. Does it want the interest though? No. So 12,204. What was the change? 14 cents. Thank you. Awesome. Thanks, guys. All right. So this one, it just says determine the value of the investment, so you don't have to subtract it. You're good because that will be the value of the investment. That'll be sitting in your account after the 10 years. Right. So right now I'm just kind of making it so we don't have to move stuff around, anything crazy with the first two, but now let's actually solve for something other than the Y. So here it says Kelly invested $2,500 for 4 years compounded semi-annually and received $843.26 in interest. What was the annual interest rate? So you see there's a little piece that you have to be careful about here. What do we have to do with the 843.26? Good, 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 good. So they'll do that sort of thing to you guys. So you have to add your interest because remember the Y represents the total amount. So plus 843.26. So we have to do that to get our Y value. So 33.43.26. Double check that I typed it in right. Yeah, we're good. All right. So away we go. So $3,343.26 equals, what's my A value? Perfect. Now we want to find the interest rate, so we're going to solve for B. So we don't know that. And then what's my T? Bless you. Yeah, you betcha. 4. And what's my B? 1/2. So again, that's going to be just a 8. Do you guys agree? All right. So we're going to take that A and divide it off. So we have 3343.26. Divide the 2,500 off. And again, yes, you could use Y1, Y2 if you wanted to. So I want to do the math and see the numbers. Equals B to the exponent of 8. So now, do you guys remember, can I just do 1/8 on both sides? Right, just, oopsie. Because here, guys, does it make sense why I'm not doing logs, right? I do not have a variable up in the exponent, right? So we've done this a million times before. And again, could I 8th root it? Would that work as well? Yeah, either one. I don't care what you guys do. You guys know which both work. So I already have that on there. So to the exponent of 1 divided by 8. So then I have 1 point. So this is where now we have to reason what we just figured out. So looking at that, guys, what's the percentage? What is it? 3 points. Go back, yes, because remember, guys, go back up to how we set these up. Is the percentage after the 1? Yes, yes. The percentage is after the 1. So the 1 you ignore. So you're looking at this piece. So there's a couple other, one other thing we have to worry about. So this is the piece we're looking at. So take that piece is actually back to a percentage is 3.7%. Now there's another thing we have to worry about. So which one am I doing? Am I dividing by 2 or timesing by 2? Timesing by 2. Because is this set up semi-annually? So this question is set up semi-annually. So the B value you're going to get out is a semi-annual rate. Okay. So this right here is a semi-annual rate. Right. And it did say to calculate a annual. So in this, could I ask for the semi-annual rate? Yeah. If I did, you'd be done. Right. But it did ask for the annual rate. So all you have to do is take the 3.7 and times it by 2. So a lot more to think about when you're doing the money stuff. Okay. So which hopefully is interesting. So that would be what, 5.4 or no, 4, 6, 7.5, 7.4. Yes. So 7.4, not what I was saying. So, which is a great rate. That's like non-existent in nowadays, right? Interest rates nowadays are like 1.8. We're lucky if you get into the 2s. Okay. Right. But if you're now or having mortgages and stuff, that's different. Now you're up at 3s or 4s, which that you're paying on your mortgage. That's actually good. Some of them after COVID and stuff were into the 6 and 8s, right, percentage on your mortgage, which adds a lot of interest to your mortgage. All right. So guys, with that, let's do. I want to. Actually, let's do 8, just one, because this one gets a little bit not messy, but the numbers aren't nice. So I want you guys to be okay that you're not doing stuff wrong if the numbers aren't pretty. So what I mean by that is, do you think compounded monthly is going to give you a yucky B value? Yes. Okay. So here, George invests $3,000 in an account which pays compounded interest of 5.3% per annum, compounded monthly. How long will it take for the necessary month for his investment to double in value? So let's put our values in. So again, I have to take that 5.3 and divide it by 12 to get my B value. Right. And again, I'm going to keep this in. So that's not my B value yet, right? So my percentage, so then my B value, remember guys, do I still have to divide, this is where it looks strange, do I still have to divide that by 100 before I make my B value happen? Yes, because remember, this is still percent. I have to change it to a decimal before I put it in. Okay, so then my B value is going to be 1.004416 repeating. Right? So if you're like, what? Go back to what we did here, the one that you guys can visualize, right? This one was semi-annually. We had to divide it by 2 to get our percentage. Then did we have to take that and put it to a decimal before we put it back into our problem? Yes. So be okay with not nice numbers for your B value because your calculator will deal with them, right? So then once you get that, then it's not horrible. So you invest 3,000, so that's your A. Your B is that 1.004416 compounded monthly. So therefore your B value is 1 over 12, and your T we're not sure. And it asks for how long it's going to take for our money to double. So what's our Y value? 6,000. So this one, guys, you have to be a little bit careful because T right now in my formula represents what? Total time in years, right? Yes, yes? Okay, so when we solve this for T, that'll give us our years, which then we can change to months. Sorry, get back there. Oopsie. So you guys go ahead and solve it. I'll solve it as well. So we have, so divide the 3,000 off. So if I go T divided by 1 over 12, guys, is that just 12T? Is that what that is? Yes. Most students, I keep writing it like that so you guys can see that compounded monthly is 1 over 12, but when you guys get good at that, I wouldn't even write that, right? 1 over 12 division, right? So times by 1 over 12, or sorry, divide by 1 over 12, right? Means reciprocate times by 12. It's just much nicer when it's written as 12T instead of T divided by 1/12. Goodness gracious. Pardon me? Oh, I forgot my 1. Silly. You probably did the same thing I just did, Austin. Forgot to add your 1 back in there because it was on your calculator. Yeah. Quit it. There we go. So did you guys get 13.1-ish years? Yeah, so then we just, so 150. To me, if it, because at 157 has it doubled yet? So you have to round it to 158. Because technically, if you round down, even though normal rounding without context, guys, you would go 157. But in this context, because it's an investment, it wants to know when it's going to double. So technically at 157 hasn't doubled. So you actually have to round up. Right, you're done. because the formula's time is set up in years when you're doing your investments. Okay. Right. Just because. Right. All right, so guys, I think that's enough that you should be able to. I'll still finish these as well. I do because the textbook doesn't have a lot of word problems. So I have, it's just formative practice for those ones that want to do more. But you can give these a go, right? There's 2, 4, 5 there, and I'll give you a few more. And then I'll, like I said, I'll work behind you as well.